Okay, so we are going to use Gaussian elimination to convert this into row echelon form and then solve the system. So first it says to write it as an augmented matrix. So augmented matrix, you have 4, 8, -4, 4, 3, 8, 5, -11, -2, 1, 12, -17. We need to make it, our leading one needs to be a 1, and then 0, 0. So we need, basically we need these to be 1s, and then these to be 0s. Oh, we don't need that one to be a 0. These to be 0s for it to be an augmented matrix. So if it's not easy to make the leading ones as a 1, leave it and wait until the end to do that. This one, on the first one, it is, right? We can do 1/4 row 1 to the new row 1, right? If we do that, we have 1, 2, -1, 1. And then if you wanted to go ahead and make these zeros, you have to do it from the original row 1 or row 2 or row 3. You can't use this one that we've already done over here in green with that one. So I'm not going to do anything. I'm just going to leave them. I'm just going to take row 2 over and take row 3 over. Usually I do it the bottom way, not the top way. But 3, 8, 5, -11, -2, 1, 12, -17. So now I'll use that new green matrix to eliminate these. So I'm going to do -3 row 1. Well, first of all, we're going to keep row 1. So let's move row 1. And then -3 row 1 plus row 2. It's going to be my new row 2. And 2 row 1 plus row 3 is going to be my new row 3. So 1, 2, -1, 1, 0. -3 times 2 is -6, plus 8 is 2. 3 plus 5 is 8. And then, what am I doing? -3. So -3 minus 11 is -14. And then on the bottom, 2 minus 2 is 0. 4 plus 1 is 5. -2 plus 12 is 10. 2 minus 17 is -15. Okay, I noticed quickly that these, right, these all have a 2 in them, and these all have a 5 in them. So those are really easy to reduce, so let's go ahead and do that. So I'll go back to green. So I'm going to keep row 1, and do 1/2 row 2 to my new row 2, and 1/5 row 3 to my new row 3. 1, 2, -1, 1, 0, 1, 4, -7, 0, 1, 2, -3. Okay, so now row 1 and row 2 are good, and we just need to turn this into a 0 right here. So keep row 1, keep row 2, and then I'll do row 2 minus row 3 to give me my new row 3. And then I have 0 minus 0 is 0, 1 minus 1 is 0, 4 minus 2 is 2, -7 plus 3 is -4. We are in triangular form. We could solve this now, but it did tell me to find row echelon form. So right here it says to find row echelon form. This is not row echelon form. I still need to make that last row right. So we're going to keep row 1, we'll keep row 2, and row 3 we're going to do 1/2 row 3 to my new row 3. And this will be our final one. One, two, -1, 1, 0, 1, 4, negative 7, 0, 0, 1, negative 2. All right, we are in row echelon form. So now we can solve the matrix, right? So this, we have z equals negative 2, y plus 4z equals negative 7, x plus 2y minus z equals 1. So y minus 8 equals negative 7, y equals 1. And then x plus 2 equals 1. X plus 4 equals 1. X equals negative 3. So the solution to our system is negative 3, 1, negative 2. Okay, we can do it on our calculator also. So we're going to make a new matrix. Matrix. Create. It is a 3 by 4. Type them in. 4, 8, negative 4, 4, 3, 8, 5, negative 11, negative 2, 1, 12, negative 17. Okay, we want to store it. We'll store that as B. And then it said to find row echelon form and reduce row echelon form of the system. All right, so menu, matrix. Number 4 is row echelon form. So what is row echelon form of the system? Okay, that's what it gives us. That's different than the one that we found, though. So row echelon form, depending on what order you do things in and what rows you leave where, could be different for different ones. So that's okay. But if we do reduced row echelon form, look how neat this is. Reduced row echelon form is just going to give you the answers. X, oops, can't really, I don't know if you can see it when I do that or not. X equals negative 3. Y equals 1. Z equals negative 2. Those are the same answers as what we found earlier. So when you're in reduced row echelon form, you get a unique answer that you don't necessarily see when you're in row echelon form. Row echelon form is not unique. Reduced row echelon form is unique.